question. Question 1.2, we have a simultaneous equation. So we have to solve for x and y simultaneously, and you've been given two equations. First and foremost, always put the linear equation as equation 1. So we're going to call that equation 1, and this one equation 2. So from equation 1, we're going to make a subject. In this one, it's quite easy because they're both just sitting on their own. They don't have anything like 2 or 3 or any number other than 1. So I'm going to go ahead and make x the subject. X is equal to, and I still have 9 here. And I'm going to go ahead and take the y over and becomes a negative y. And this is now our equation 3. Then, in order to go ahead and solve for y, we're going to substitute equation 3 into the equation you have not touched yet, which is equation 2. Okay, so let's go ahead and rewrite that. We have 2x squared. So we have 2x squared, and so every time you see x, replace it with 9 minus y. So we're going to say 2, and we have 9 minus y squared minus y squared is equal to 7. Okay, simplify. As you can see, you have a squared here. So you need to actually fix that first. You have to, first of all, simplify that. So we still have the 2. Now, when you distribute that, you can do it that traditional method of doing this and then distributing, which takes long. But what I'm just going to do is I'm going to go ahead and square the first term. 9 squared gives you 81. And then I say the first term times the second term, which is going to give me a negative 9y, and then you multiply that by 2, which gives you a negative 18y. Then lastly, you square the last term, negative y all squared is going to give you positive y squared. Okay, then we have minus y squared is equal to 7. So just be very careful here. Then we're going to distribute. So we're going to say the 2 times the 81, which is going to give us 162. And then the 2 multiplied by the negative 18y, which is negative 36y. And then the 2 multiplied by the y squared, which is positive 2y squared. Then minus y squared is equal to 7. Okay, we can bring that 7 over. So minus 7 equals 0. Okay, so as you can see, I'm going to put this in the order of the exponents. So let's start off with the 2y squared minus y squared, which is going to give us a y squared. We're done with that one now. And then you see that this is the only thing with a y. So minus 36y. And then we have 162 minus 7, which is going to be 155 because the, 7 is made of 5 and 2. So 160 minus 5 is 155. So positive 155 is equal to 0. And you have to factorize. Okay, now I know it's exams. When you're in the exam room, you're trying to save as much time. So I will actually just show you a quicker method. What we can do here, instead of looking for our factors, is you can go ahead and use the quadratic formula, just don't show them that you've used it. So what I'm going to do is I'm going to use the quadratic formula here. It is negative b, and my b here is negative 36. So I say minus, and then negative 36, plus minus, let's start with the plus, and we have the square root of b squared, which is our negative 36 all squared. Also, if you're hearing sounds in the background, please just try to ignore it. They're doing some work outside. And then minus 4 AC. So 4, and then A is, as we can see, A is 1 and C is 155. Okay, all over 2A. And we have that. So as you can see, the first factor we get, or the first solution we get, is 31. So here is what we're going to do. We're going to open up two brackets, of course, and say is equal to 0. But then what we're going to do here is we're already solving for y. So it's either that y is equal to 31. So think about it. If y is equal to 31, what is the factor that you had that helped you to get 31? It must have been y minus 31. Okay, because you'd have said y minus 31 equals 0 and taken the negative 31 over. To find the second factor, I'm just going to change that, and then I get 5. So I know that the solution that I get is y equals 5. So the factor must have been y minus 5. Okay, so that's how that first part is solved. And as you can see, we have the solutions for y, or really the equations for y. And I'm just going to go ahead and call that equation number 4. Now, to finally solve for x, you can substitute your equations of y, equation 4, into the equation for x. That's equation 3. So substitute equation 4 into equation 3. Okay, so let's go to equation 4. And this is what equation 3 is. X is equal to 9 minus y. So we're saying x is equal to 9 minus, and the first y value we have is 31. Okay, so therefore x is equal to, and we get negative 22. Okay, and then you can say, or x is equal to, and then that is 9 minus your second value, which is 5, and x is therefore equal to 4. So those are our solutions. When x is equal to negative 22, y is equal to 31. X is equal to 4, y is equal to 5. Okay, moving on to the next question. And then we have the last question in question 1, which is 1.3, and it says, given p is equal to 1 minus a and t is equal to 1 plus a times 1 plus a squared times 1 plus a to the power of 4, and this goes on until 1 plus a to the power of 512. We need to determine the value of p times t in terms of a. Okay, them already saying in terms of a just means that when you finally multiply the equation of p with the equation of t, you're going to just get your answer, and it's going to be in terms of a. Okay, so how are we going to work this out? Let's look at this. This equation, or these equations that they gave us, the first one is just 1 minus a, but then the second one is what we need to really look into and figure out. So let's actually just try to understand this equation quickly. You see that we have 1 plus a, and then 1 plus a squared, and then 1 plus a to the power of 4, and then 1 plus a to the power of 512. The only thing that is changing is that exponent on the a. So let's just see what they did. Here the exponent on a is a 1, and then we have the exponent being a 2. How do we get from 1 to 2? Well, we could say 1 times 2, and then that gives us 2. And then we have a to the power of 4. So how do we get from 2 to 4? You could also say 2 times 2, and that will give you 4. And so if that is really the pattern, then we should have it like this. And I can't just assume it is the pattern. I'm going to test whether it is the pattern or not. So I'm saying that our t, and I'm just going to say t equals, so I don't have to keep writing t is equal to. And let me just rewrite what is there first. So I'm saying the next term, because it seems like these exponents, they're just being multiplied by 2. So 1, and then 1 times 2 is 2. Then 2 times 2 is 4. Then 4 times 2 is 8. So the next term should be 1 plus a to the power of 8. And then 1 plus a to the power of 16. And this should keep going all the way to 1 plus a to the power of 512. Now, this is what I was saying, where I said I can't just assume that that is the pattern. I should find out whether it is or not. If truly it is the pattern, then when I go from this a to the power of 4, right? Or let's just focus on that 4. When we go from that 4, we should be able to keep multiplying that number or the previous number by 2, and we should be able to get to 512. If we can do that, then this is really our pattern. So let's think about that. So we could say 4 times 2 and we get 8. We really do have 8. 8 times 2, we get 16. 16 times 2, we get 32. 32 times 2, we get 64, right? And we'll keep going, and it's going to take long. So I don't really have to do that, honestly speaking. I wanted to continue multiplying, but that's very unnecessary. That's going to take really long. All you have to do for you to know whether this is true or not is to find out if 512 can actually be divided by 2. And then that would be true, because these are all just factors of, well, not factors of 2, because 1 is not a factor of 2, but we are counting in 2's, we're multiplying by 2. So the only way that that could really end there is if it is divisible by 2. Okay, you can on your own go ahead and multiply, but I actually did try, and let me just test it quickly. I'll just check it out and see if it works. And let me actually just show you a quick way of doing that on your calculator. So if you have a calculator, this shouldn't be difficult to do. All you're going to do is say 1 times 2 equals 2. Then say times 2 equals. Then the calculator starts to realize what you're doing. Like, oh, okay, so we're just multiplying by 2 the whole time. Then if you say equals, it will say 8. And then equals, and just do that. And if you see 512, then you know it's true. So there we go. You don't have to do that. So that is the pattern for real. Okay, so it ends at 512. Great. Now we know what our pattern looks like. We even know how to draw it out completely. That's a good thing. Now we just have to answer what they told us. Well, what they want us to do is take P and multiply it by T, and we need to express that expression in terms of A. So let's go ahead and multiply P times T. So we're saying P multiplied by T equals, and I'm just going to rewrite this again. Okay, P first of all. P is this. It's completely different. Let me write it in red. P is 1 minus A. And then we're going to multiply that by that. Okay, let's go ahead and multiply. So let's see what happens when we multiply it first. Do you see that these two terms, well, they're not terms, but these two brackets that we're multiplying, right? They are going to form difference of two squares. Or they're really just the expansion of difference of two squares. So it's 1 and 1, A and A, minus and plus. So if you multiply them, they would become 1 minus A squared. And that is going to get multiplied to everything else that is still left. And now you see another 1 minus 1 plus A squared, which is going to be difference of two squares with that one again. So when we multiply there again, we get this situation. And I'll just continue writing that just so that they can see, okay, that you are actually simplifying. Now, I'm not going to simplify all the way because you can already see what's going on at this point. When you multiply these two together, you're going to get 1 minus A to the power of 4. Which is going to multiply with that one to give you 1 minus A to the power of 8, which is going to multiply with that one to give you 1 minus A to the power of 16, and as you can see where we're going. So let me actually just figure out what the one before this would be. That one would be, so I'll just rewrite everything. Let me paste it in. So as you can see, the way the pattern keeps going, you keep having these two being the same, and so they form difference of two squares, and then they become the next one, right? And as you can see, the next one has an 8, but the previous one had a 4. So it's always going to be that divided by that. So to figure out what was before the 512, you could say 512 divided by 2. Okay, so if you said 512 divided by 2, you're going to get 256. So I know now the previous one before this must have been 1 plus A to the power of 256. Okay. And so again, in a nutshell, what's going to happen is you multiply this one with this one. Then that would become 1 minus A to the power of 8. It would multiply with this one and become 1 minus A to the power of 16. It will multiply with that one, and then it keep on going. Okay. And then you're going to get to a point where you will literally just have 1 minus A to the power of 256, which would multiply with this 1 plus A to the power of 256. And of course, you still have that 1 plus A to the power of 512. Then when they multiply, they will become 1 minus A to the power of, remember the bases are the same. When you're multiplying, you need to add the exponents. That's actually what's going on there. When you add the 256 and the 256, they give you 512. And then you're going to multiply that 1 plus A to the power of 512. And then we're just going to have to find this answer. And then that is going to give us, again, it's difference of two squares. So it's going to be 1 minus, base the same, multiply and add the exponents. It's going to be A to the power of 500, and 500 is 1000. 12 times 12 plus 12 is 24. So 1024. That is what P multiplied by T is. It is 1 minus A to the power of 1024. And that is our answer there. Okay, so that was a long one. They keep introducing things like this. You saw that in last year's paper as well. Okay, so that is it for question 1. And then we move on to question 2, which is going to be in a separate video.